So we're just going to do lines today. So let's remember some things from Friday. We said on Friday that all inverses reflect over what line? Do you remember? Y equals X. So inverse functions or opposite functions are always going to reflect over the line y equals x when you graph them. Now, when we solve an equation, we'll do a couple of these today. When you're solving an equation to find the inverse, what did you need to switch in the equation? You needed to switch the x and the y, and then you had to solve this new equation for y. You have to have a y equals, or another way we write y equals with function notation was f, the little -1, that means inverse of x. So we'll see that notation too, as inverse of x. All right, and finally, if you're given a graph, or you just think about a graph, we did this on our activity. In order to graph an inverse, all of the ordered pairs are switched. So instead of x, y, it would be the point y, x. Right? Does that remind you of anything from geometry? Rotations. Remember you had, you did rotations and reflections? Well, remember, in geometry, if you can remember that far back, when you did a reflection over the line y equals x, this was the rule you used to reflect that object, that quadrilateral triangle, was you flipped the ordered pair x and y. So those geometry rules are also algebra rules. All right, so let's jump right into a couple examples here. We did something like this on Friday, so we're not going to graph a lot today, but we just review here. I have y equals 3x plus 6. If I'm going to find the inverse, we said we have to switch the letters x and y. So I have x equals 3y plus 6. What would I do to get x by itself? Minus 6. Yep, move the 6 over next to the x. So I'll have x minus 6 equals 3y. And then I divide everything by 3. So your new equation would be x over 3 minus what? 2 equals y. And I'm going to put a little y -1 for y inverse, so I know the difference between the two functions. All right, that's the equation of the inverse. Now, I have this box underneath there, and I said, what's the y-intercept of the original equation y? All right, so just look at the equation. What do you get as the y-intercept? 6, right? So I'm going to write it as an ordered pair. You could just write the number 6 if you want, but 0, 6 is the y-intercept, right? Now, what's the x-intercept of this? How could you find it? A couple ways. I'm not really worried about how we find it, but what do you want to do to find the x-intercept? What do you think, Skylar? Yeah, so you could set the y equal to 0 and solve for x. Okay, we'll do it the long way this time, and we'll do the short way the next time. So if I put 0 in for y, I'd subtract 6, get -6 equals 3x, divide by 3, and what's the x-intercept? -2. All right, so my net x-intercept would be -2, 0. Now let's notice something about our inverse function, y inverse. What's the y-intercept of the inverse function? -2. So the y-intercept for the inverse is -2. And if I did the same thing to find the x-intercept, if I had x over 3 minus 2 and I set that equal to 0, I'd add 2, right? So I get x over 3 equals 2. And what does x equal? 6. What do you notice about the x and the y-intercepts? They switched, right? They're opposite. So the x-intercept became the y-intercept, and the y became the x. Okay. Let's look at the next one. 7x plus 18 over 2. All right. What do I do first to find the inverse? Switch x and y. Now this f of x is the same thing as y. So I would just write x equals 7y plus 18 over 2. Now, how would you get x by, or get y by itself? Excuse me. Multiply both sides by 2. So I will have 2x equals 7y plus 18. Then subtract 18, and then we'll divide by 7. Good. So I'll get 2x minus 18 equals 7y. Now there's 2 ways you can write your answer. You'll see answers written a couple ways. You could just divide the whole left-hand side by 7 that way and get 2x minus 18 over 7 is your inverse. One reason I don't like to write the answer that way too often is because if you had to graph this, it's just easier sometimes to see that that's 2x over 7 minus 18 over 7. But it's the same equation, just written a different way. I really do not care how you write the answer, either way. Okay. So let's talk about the x-intercepts and the y-intercepts. Let's see. What is the y-intercept of the original graph? Skylar? How did you get 9? Yeah. So this is, remember, if we use the same rule, this is 7x over 2 plus 18 over 2, which is 9. And that constant is our y-intercept. So I'll just put a 9 here. You know it's the ordered pair, but 9. X-intercept of f of x. Well, do you want to do the math or do you want to do the fast way? Fast way. Okay, so you could use your calculator. Let's see. You can use your calculator, but this one's actually going to be a fraction. So I'll even make it faster for you. I'll graph it up here. Pull out your calculator though, because we'll do one at one point. But I'll just graph it for you here. We're just going to try and see the pattern. So what's our equation? Let's see. 7x plus 18 over 2. Alright, you're okay. I'll graph it here. So 0.9 is our y-intercept. My x-intercept is negative 2.571. So there's our x-intercept. Negative 2.571. I forgot the 1. There we go. And if you wanted to know the fraction, I think that's, let's see, negative 18 over 7. If you really care what the fraction is. I call it the cover-up. I'll show you in a second. What's the y-intercept of my inverse? Negative 18 over 7, which I said was the same as that decimal, right? So my y-intercept here is negative 18 over 7. And what do you think is going to be the x-intercept? 9. Now, if you wanted to check, we could graph it. So we had, 2x minus 18 in the numerator over 7. No, I did that wrong. I forgot that. 1. That would do it. There we go. And my x-intercept here. If I look at those 2 lines, do they look like they would reflect over y equals x? Yes. Yes. Okay. One more, and then we'll switch it up. Negative x over 5 minus 1. So let's start. What's the y-intercept of h of x? We'll start with the y-intercept. 0, negative 1. Okay. So 0, negative 1. What would be the x-intercept? If I put 0 in here, and I added 1, I'd have 1 equals negative x over 5. Times 5 is 5 equals, divide by negative 1? Negative 5. Now, how else could you find the x-intercept on your calculator? You guys don't have decimals. How could you use your calculator to find the table? Okay. What other feature could you use on your calculator? Can you trace x-intercepts? Do you remember what it was? Second trace. What option did you choose? That's intersect zeros. Right, so you could find that on your calculator using a 0. All right, let's find the inverse this time. So I'll switch. H of x is the same as y. So I'll have x equals negative y over 5 minus 1. And that negative can be in front. It can be on the numerator or denominator. It really doesn't matter. I'm going to start by adding 1. So I'll get x plus 1 equals negative y over 5. And let's multiply everything by 5. So we get 5x plus 5 is negative y, but on that time, what do I have to do? Divide by negative 1. So that switches all the signs. Negative 5x minus 5 equals y, which is our h inverse of x. So when I look here, what is the y-intercept of my inverse function? Negative 5, which is the opposite of the x intercept of the original. What's the x-intercept? Negative 1. So if I added 5, I get negative 5 divided by negative 5, which is negative 1. Now, real quick, before we move on, one other thing I think we pointed out last week, but I wanted to be sure. What's the slope of the original function up here? What's the slope of h of x? Negative 1/5. What's the slope of our new function? Negative 5. What did we say was true about the slopes? They were reciprocals. Not opposite reciprocals, they're both negative, but the fraction flips. Alright, so let's look at a graph one here. Same, we just did this one. This is C. So we have negative x over 5 minus 1. What did we say what line do they all reflect over? Y equals x. So let's graph y equals x first, and then we're going to graph the function and its inverse. So really carefully, we'll graph y equals x. I asked you a question that I forgot was on the paper below. It's okay. We already know the answer to that. So I want you to first graph h of x. So we started at negative 1 as our y-intercept. And we just said the slope of that line was down 1, right, 5. So we can graph h of x here. And go ahead and label it once you graph it. Oops. It's not a great line, but that's okay. I'll try again. There we go. There's h of x. And then h inverse of x was negative 5x minus 5. So it was negative 5x minus 5 here. So we start at negative 5. Then our slope goes down 5, right, 1. I know we know how to graph the line, but it is useful. It's helpful to be able to make sure we can do that. Because we graph y equals x, we can visually see. So here are the ways that we check our work, basically. We can graph them on your calculator even, and see that the two functions reflect over the line y equals x. The next thing we can notice or check is what we just talked about, the relationship of the slopes. We said the slopes were reciprocals of each other. I can't spell and talk at the same time. Oh, I was right. Reciprocal. They were reciprocals of each other, right? And then the other thing we can do is check points on the graphs. So on the original graph, we have the point 5, negative 2, right here. Here's 5, negative 2. Now, if we know about inverses, what do we know about their x's and y's and all the points? Everything on an inverse does what? They stay the same, or the opposites? Do they switch? They switch, right? The signs stay the same, right? So 5, negative 2 is on h. What point should be on the inverse? Negative 2, 5. So let's check. Negative 2, 5 is on the inverse. So that's another way to check the work. All right, so we have 3 ways to check our work. Graph it, see if they look like they reflect. Check the slopes, see if they're reciprocals. See if a point is the opposite. Same with the intercepts. I'm going to show you a third way now. Flip your paper over. Let's talk about composition real quick. We'll get back to how this helps us in a second, but let's do some composition. We did some composition last week. In example 1, so the very beginning of our notes, we found that f of x was 3x plus 6, and g of x, its inverse, was x over 3 minus 2. That was the first problem we did. Let's do 2 compositions here. We'll make it quick. F of g of x. All right, what function am I putting into the other for f of g? Putting g into f. All right, so let's take this function of g right here and put it into the function of f for x. So 3 times, instead of x there, I'll put x over 3 minus 2, and then plus 6 on the end. Now what happens when I simplify this? I'll have 3x over 3 minus 6 plus 6. What happens to the 6's? They cancel, okay, which is 3x over 3, which equals x. All right, now, you might be thinking, okay, I can do that in my head. Why is she writing all this down? Because we need to make sure there are rules about how you can cancel things off. I implore you to please, for now, I know this is easy because it's a line. Tomorrow when we get to things with cubes and sevenths and all kinds of weird exponents, you can't just cross whatever you want off in whatever order you want. There is actually mathematical order and way to do it. So I'm making sure I write this all down so you see I have to kind of go backwards order of operations. So I had to do the plus and the minus before I could cancel in the fraction with division. Okay? So we got x for the first one. Let's compose the other way. Now let's put f into g. Okay, so I'm going to take, instead of x here, I'll put 3x plus 6 in the numerator over 3, and then minus 2. So when you get 3x over 3, what does that give you? X, okay, plus 6 over 3, 2, minus 2. What happens with those 2's? They cancel, and you get x. What was the result of both compositions? X. Okay. Okay, something happened. Let's see what it means. Let's try the next one. This was the second problem we did. 7x plus 18 over 2 and 2x minus 18 over 7. We said those were inverses. Let's see what happens when we do their composition. So f of g, I'm going to put g into f here. So I'm going to have a lot of fractions within fractions. Right, I'll have 7, 2x minus 18 over 7, plus 18, all over 2. Fractions within fractions. Now, I think it's going to be easiest, instead of, you can distribute this 7 here. I think it's going to be easiest here to just cross those 7s off, right? I can cancel those. Because that way, it saves you some work, because you have now in the numerator 2x minus 18 plus 18, all over 2. You can do it the other way, but it's a little bit more work. What's going to cancel off next? The 18s. I have to do the 18s next, which gives me 2x over 2, which equals x. We're getting a lot of x's as our answers here. We'll just do it one more time. Now you have g of f. Let's go the other way. Let's see if we get x again. Okay? Because it might need something. So f into g, similar kind of simplifying here. 2 times 7x plus 18 over 2 minus 18 all over 7. And I think the easiest way to do this would be to cancel the 2's off to start. I can cancel those. Because then I get 7x plus 18 minus 18 over 7. 18's go away. 7x over 7 is x. I got x again for both compositions. So, that obviously probably means something. Here's a rule. From the examples above, this wasn't a proof, but we're going to make a conjecture that actually ends up being true. If I have two functions, if they are inverses of each other, both compositions, f of g of x and g of f of x, will equal x. If you are inverses, both compositions will equal x. If you get something other than x, they're not inverses. Okay. So when we do this next, we're actually going to be doing a proof. Right? We're doing proofs a couple times this year. I know it's not a two-column proof. We've talked about this. Algebra proofs are different than geometry proofs. So let's do a proof here. Let's prove to me, or determine, whether or not H and M are inverses. Okay, so in order to do this proof, in order to decide if they're inverses, I have to find h of m of x and m of h of x. You have to do both compositions. I know that seems like really tedious, but that's the way it works. You have to do both compositions. There are other clues you could use, right? Like you could use the slope rule. The slope here is 2 and the slope here is 1/2, but that's not foolproof. So let's find h of m of x. We're going to put m into h first. So 2 times x plus 1 over 2 plus 1. Now when I simplify this, what do you want to do? Cancel the 2's? Okay. So I get x plus 1 plus 1, which equals x plus 2. Oh, so that one didn't give me x. Let's make sure the other one doesn't give me x as well. So now we go the other way. Put h into m. So we'll take 2x plus 1 plus 1 all over 2. Well, 1 and 1 adds up to 2. So I have 2x plus 2 over 2. What does that simplify to be? X plus 1. Well, did I get x for either composition? No. So are these functions inverses? No. If you wanted to, you could graph 2x plus 1 here. Like if you visually looked at these, and then the other one, what was that equation? X plus 1 over 2. You can see those would not reflect over the line y equals x. So they're not inverses. All right, one more. I think this is it. Last one. B of n and t of n. So let's find b of t of n. I'm going to put t into b first. So I'll have 4 times negative 16 plus n over 4 plus 16. All right, what do you want to do first? Cancel the 4's. So I have negative 16 plus n plus 16. Those 16s go away, and you got n. That's good. That's what we were looking for, but sometimes the other way doesn't work. So let's still try. T of b. All right, I know it's annoying. We got to do both. So I have negative 16 plus my function 4n plus 16 over 4. What happens in the numerator? 16s cancel away. So you get 4n over 4, which is n. If I get n for both, they are inverses of each other. Not too hard today, right? Just reviewing some skills of how to find an inverse, some rules about how points change, intercepts change, slopes and reciprocals. The composition part's new. Yes?
So, if you like do the first one and you don't get it exactly as this,
Well, yes, but what if you made a mistake? So, you know what I mean? So that's why I typically say show me both compositions, because if you then got x for the second one, then they might not be inverses, but then you might have to go back and double check, like, okay, did I do it correctly? For linear, it's not that big of a deal because they're pretty easy just to cross off and cancel. The ones we're going to do tomorrow are going to be more involved, so that's why I would check both. Like this one here, you probably didn't make a mistake. Tomorrow, I'll look. A good question. I'll ask him on Instagram what his policy is on that. Okay, so we're consistent. All right, a little bit of practice for you, really not that long. Answers are on the back page. Couple inverses, couple compositions, and then some graphs. All right.